Okay, so this is the second example problem. So a runner starts from rest and accelerates at a rate of 3 meters per second squared until they reach a velocity of 20 meters per second. What was their displacement in that time? So let's look at what we know. When someone starts from rest, that means they're starting with the velocity of 0, because if you're at rest, you're not moving. So initial velocity is going to equal 0. They accelerate at a rate of 3 meters per second squared. So that's just going to be our acceleration. What that means is that every second they're going 3 meters per second faster than they were in the previous second. So they're accelerating at that rate until they reach a velocity of 20 meters per second. That's going to be the final. What was their displacement in that time? So remember, displacement is this triangle X, basically looking how far they moved from their starting point. That's gonna be our question mark. So if we look at these equations over here, the one variable that we do not have is time. So looking at these equations, this equation has time, this equation has time, this equation doesn't, and this equation has time. So we're gonna use this equation because this has the 4 variables that we have here. So we are trying to solve for this delta x right here. So first I'm going to manipulate the equation, and then I'm going to plug in the numbers at the end. So we have this plus this. So I'm going to subtract initial velocity squared from both sides. So now I'm going to have final velocity squared minus initial velocity squared is equal to 2 times acceleration times the displacement. Now, I need to get rid of this 2 and this a. So this is all multiplied together, so I can actually just divide by this 2a. If you want to do it in 2 steps, you can, if that helps you out. If you want to divide by 2, then divide by a, but you can just do it all in one step. And see, like, these would cross out. So now we're left with displacement is equal to final velocity squared minus initial velocity squared over 2a. So let's plug that in. Final velocity, 20 meters per second. That whole thing is going to be squared minus initial velocity is 0. That's just going to that'll just be 0 over 2 times acceleration, which is 3 meters per second squared. So let's do this in my calculator. We have 20 squared divided by 2 times 3, which we know is 6. And we're left with 66.66. So we'll write displacement just gonna round it there. And the unit for displacement is meters. And if you ever can't figure that out or remember that, let's look at what we have. So if we have meters per second squared, so that would be meters squared over second squared, if we actually squared it out. And we're dividing that by meters per second squared. So what you would actually be doing here is meters squared over second squared. That would be multiplied by meters, second squared over meters. If this is confusing, just ignore it. I'm just showing you that this would cancel out, and then the meters squared would cancel out with that. So you would just be left with meters.